Stop planting more trees if the goal is real carbon capture in a small growing space. That sounds wrong, but honestly, the results prove it fast. This is where most people miss it. Carbon capture is not just about storage, it's about rate. A tree stores carbon well, but slowly. A fast-growing system stores less per cycle, but cycles dozens of times per year. Multiply that out and, well, the numbers change completely. Most governments don't fund this heavily. And it's not because it doesn't work, it's because it's decentralized, small-scale, and harder to control or standardize. A forest project is easy to measure on paper. Thousands of small, fast systems. Yeah, that's harder to regulate, harder to monetize at scale. Lighting is honestly the biggest lever here. This is where something like the Spider Farmer SF1000 LED grow light really comes in handy. There's a link in the description below, and just so you know, using that link may earn a small commission at no extra cost to you, and those commissions actually help support a dog rescue. Under consistent light intensity, somewhere around 200 to 400 micromoles per square meter per second, growth becomes stable and, well, pretty predictable. Without proper light, the system just slows down. Outdoors, clouds and seasonal shifts reduce efficiency, but indoors or in controlled setups, light consistency really changes everything. Now here's the deeper part. Carbon capture here happens through photosynthesis, just like any plant. But because these organisms are mostly soft tissue, they actually convert carbon faster. Less lignin, less structural delay, and more direct biomass accumulation. Here's the trade-off most people ignore. Fast systems require management. You can't just plant and forget. Nutrients need replenishing. Overcrowding reduces efficiency. If the surface gets too dense, light penetration drops and growth slows. That's why harvesting regularly really matters. Remove about 30 to 50% of the biomass every few days. This keeps the system in peak growth phase. It's kind of like pruning plants to encourage new growth, but way faster. And that harvested material, it's not waste at all. That's actually where the real value compounds. It can be added to compost piles to speed up breakdown. Mixed into soil, it improves microbial activity. Used as mulch, it feeds the surface layer quickly. Compared to dry leaves or wood chips, this material decomposes rapidly. That means faster nutrient cycling back into your garden beds. Now think about this in a real food-growing setup. Raised beds often struggle with slow organic matter turnover. Adding fast-grown biomass weekly really changes that dynamic. Soil becomes more active, more biologically alive. And for hydroponic growers, this becomes a closed-loop opportunity. Waste nutrients from one system can feed another. Carbon capture becomes part of nutrient cycling, not just a separate concept. This is also where airflow plays a role. Stagnant conditions reduce gas exchange. Gentle movement increases carbon dioxide availability at the surface. Even a small fan can improve growth rates noticeably. Temperature matters too. The optimal range sits between 20 degrees and 30 degrees Celsius. Below that, growth slows. Above that, stress increases. Stability always beats extremes. Now, back to the bigger question. Why isn't this everywhere? Well, because it doesn't fit the traditional model. It doesn't require massive land. It doesn't need long timelines. It doesn't rely on centralized control. It works in backyards, greenhouses, and small farms. And that makes it less attractive for large-scale funding structures that prefer big, visible projects. But for serious growers, that's honestly irrelevant. What matters is results. Another key advantage here is water efficiency. These systems recycle water continuously. Evaporation is minimal if covered or managed properly. Compared to soil systems, water use per unit of biomass is significantly lower. Now let's correct a common myth. More carbon capture doesn't automatically mean better for your garden. If that biomass isn't reintegrated properly, nutrients can become imbalanced. Dumping large amounts at once can cause nitrogen spikes. That leads to excessive leafy growth and weaker fruiting in crops like tomatoes or peppers. The better approach is gradual integration. Small, frequent additions. Think weekly, not seasonal. This keeps nutrient levels stable and avoids stress on plants. This is also where light consistency comes back into play. The Spider Farmer SF1000 LED grow light ensures uniform coverage, which prevents uneven growth zones. That matters because uneven biomass leads to inconsistent harvesting cycles, and consistency is kind of the whole point of this system. Now consider scaling. A single tray is useful. Multiple trays turn this into a system. Stack them vertically under proper lighting, and output increases without increasing your footprint. That's where the 5 times more carbon than trees claim actually starts to make sense. In practical terms, it's not about replacing forests, it's about maximizing output per square meter. And for growers with limited space, that's everything. Another layer here is integration with aquaponics. Fish waste provides nutrients, biomass absorbs them, water gets cleaner. It's a loop. That's not just theory. That's already being used in efficient systems worldwide. It's just not widely talked about in mainstream gardening. Now, a quick reality check. This is not zero effort. It's low space, high efficiency, but it does require attention. Skip maintenance and performance drops quickly. But compared to waiting years for slow systems, this is immediate feedback. Adjust something today, see results in days. That's what really makes it powerful. And that's also why it fits perfectly into serious gardening setups. It's measurable, it's adjustable, it's scalable. Most importantly, it directly improves growing conditions. Better soil biology, faster nutrient cycling, more control over inputs, and yes, more carbon captured in the process. The final piece is mindset. Stop thinking in terms of static systems. Start thinking in cycles: growth, harvest, reuse, repeat. That shift alone changes how a garden performs, and once that loop is running, it becomes self-reinforcing. More biomass leads to better soil. Better soil leads to stronger crops. Stronger crops produce more organic matter. The cycle accelerates. If the goal is better results, not just theory, this approach delivers. Subscribe and share if real practical techniques like this matter more than surface-level tips. And if setting up a controlled system is the next step, the Spider Farmer SF1000 LED grow light is a solid place to start.